All right. Well, good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. If you're just tuning in for the first time this month, we have been celebrating space exploration. So we've been talking to scientists, to engineers, to astronauts, all the really cool people who are exploring our solar system and beyond in really exciting ways, but also kind of turning that lens back and looking at the planet. So if you head over to exploringbytheseat.com, you can find all the events that we still have coming up this month. Believe it or not, we still have a ton of events to go. I think by the time this month ends, we'll have hosted about 60 or so live events for classrooms across North America. So always a lot going on at Exploring by the Seat of Your Pants. Well, today's guest, I'm so excited to have Marc Rayman joining us today. Marc is a scientist and engineer. He has been a space and astronomy enthusiast since he was 4 years old. He's worked on a number of really cool interplanetary missions, including as the chief engineer and mission director for the Dawn spacecraft. So Dawn began to orbit Ceres, becoming the first probe to orbit a dwarf planet. He is now NASA JPL, so Jet Propulsion Laboratories, chief engineer for mission operations and sciences. While his favorite thing to do is learn about space exploration, he also has other hobbies like international folk dancing, photography, hiking, and he has a black belt in karate. So I guess we better behave today. I'm going to bring Marc live into the call. Marc, it's so good to have you joining us live today.
Thanks, Joe. It's nice to be here with you and with all of you students. I'm delighted you're joining us today.
Amazing. Well, Marc, I always love when you join us. You always have such a great presentation taking us on some of those missions. So I'm going to let you take over for a bit. And then we've got a Q&A portion with our classrooms. We've got lots of classrooms hanging out with us today.
Great. I'm really glad you're all here, especially under what sometimes can be difficult circumstances these days because of COVID-19. But I think it's going to be fun to spend the next little while just talking about cool space missions. As Joe said, I've loved space since I was 4 years old. When I was in the 4th grade, I decided I wanted to get a PhD in physics, that is, become a scientist and work at NASA. And I feel like I'm getting to live a dream come true doing what I do here at NASA's Jet Propulsion Laboratory. So I thought I'd just show you some slides from one of my recent missions. So I'm going to share my screen here. And then it's just to give you a little bit of a feel for this mission called Dawn. And then after that, I will be happy to take questions. And I know we're going to be interrupted briefly because I probably won't finish before our friends in Iowa have to leave. And so I'll answer some questions in the middle. But these are a couple of my spacecraft here. The big one is called Dawn. The smaller one in the lower left is Deep Space One and some of the places they've been. And I'm mostly going to tell you about Dawn here. You know, I don't know if you ever are lucky enough to spend some time gazing at the night sky. I always love to do this. And of course, you don't always get to see as many stars as this, but sometimes you do. And you know, if you think about it, any one of those stars, take that one there in the middle, really could be something a lot more interesting than just a pinpoint of light. And in fact, this is a picture of Vesta, which for 200 years looked like just one of those pinpoints of light until the Hubble Space Telescope, our most powerful telescope, got this picture. But if you really want to see a clear view, you have to send a spacecraft out there. And that's what we did. And the Dawn spacecraft traveled out past Mars to the main asteroid belt between Mars and Jupiter to get this close-up view of this alien world that's 300 miles in diameter. And in the interest of time, I'm not going to spend a long time here, but I do want to show you. So see this group of craters here. We call it the snowman. And I'm going to show you a close-up picture of that. Here they are here. And you can just see a lot of different cool things here. A lot of craters here. Here's an area that doesn't have so many craters. Here are some canyons here. In fact, there are more than 90 canyons on this alien world that are comparable in size to the Grand Canyon in the United States. So I always think that's a really cool place to have explored. But Dawn not only explored this place Vesta, it also went to dwarf planet Ceres that Joe mentioned. And there you can see it there. It's the first spacecraft to go to a dwarf planet. and the only dwarf planet in the inner solar system. And you can see it has a lot of strange features, but to me, the coolest is that bright area inside a crater. So here's a crater that's almost 60 miles across. I mean, think of whatever city you live in. Your city would only be kind of this size in this strange, bright, mysterious feature in the center. And when you see that, it makes you want to fly in closer for a better look. And that's exactly what we did. Now, before I show you an even better view of this, I'm going to zoom back out so you have the perspective here. So now we can change our view a little bit. So we're looking at it sort of from an angle. And now let's zoom in. And we flew our spacecraft down to very low altitude, not much higher than jets are when they fly across Canada or the United States. And so we were able to get some amazing views, and I'm going to show you some of them. First is on the crater wall here. Now, this crater wall is several miles high, but I just think this is a cool close-up view with these rocks sticking out of the wall, and you can see where some of them have slid down a little bit through the dirt, but got stuck. And I think that's kind of neat. And in this weird bright material here, just look at this alien landscape, unlike anything you see on Earth, with this strange combination of bright and dark material. Here's a long canyon with a V shape in it, very sharp bottom. And now we'll zoom in some more on the main bright area here in the center. And now I'm going to flip you around to the other side. So we're looking north. Now we're looking south. And I'm going to show you still more detail of the center. And all these pictures I've shown you so far are black and white. But Dawn carried other sensors that can allow us to see differences in the material there. And so in this next view, you can see I'm color coding this reddish to show you the material that's a little bit different from some of the others. And we can sort of zoom around here, fly around, and see this weird landscape. And what we now know is that Ceres has underground salt water. So water like the ocean, salt water. And sometimes it comes up to the ground, to the surface. And then when it does, the water evaporates and it leaves behind the salt that was dissolved in it. And so this bright material is salt that came from underground salt water. And I just think that's really cool. To think that this alien world has underground salt water. Now I'm going to fly us back higher up so we get one last view of that bright area. And now here's a different view of Ceres, and you see this bump on the horizon here. And so we can zoom in on that and find out that in fact, that's a volcano on Ceres. But unlike on Earth, on Earth, volcanoes erupt with hot lava. On Ceres, everything is colder because it's farther away from the sun. So what erupts from the volcano on Ceres is a mixture of ice and water and rock and salt. And so it's sort of like a muddy, icy mixture. But that made this volcano that's thousands of feet high. And I want to show you one more neat place on Ceres. This is the bottom of a crater here. Here's the wall of the crater. So it's a close-up view. And this wall is a few miles high. So now, see this trail of little imprints? These craters on the wall, we realize are from where that rock at the bottom bounced down the crater wall. And as it bounced, it left like footprints on the way down. And I just think it's really cool to be able to see that trail and see the rock that made it. And in fact, if you look around, you can see there's another trail. And sure enough, at the bottom, there's the rock. And in fact, you can see other places where there are rocks at the bottom of these trails. And one of the things that's so cool is to be able to get so close to this alien world that we can see these signs of recent activity. That is, it's not just a dead place that's where nothing ever happens. Things change, and these rocks tumble miles down this wall and leave evidence for you and me to see when our spacecraft is there. And in fact, up on the crater wall, you can see there are more things that are ready at some point to give way and fall the rest of the way down. So that's kind of a quick view of some highlights on Ceres. But I just wanted to mention that Dawn uses technology right out of science fiction. So you see in the center there the Star Wars TIE fighter that the Empire used to fight the Rebel Alliance. You know, the good guys are the Rebel Alliance. And the Star Wars TIE fighters, TIE, T-I-E, stands for Twin Ion Engine, because that was the most futuristic, coolest thing that the people who made Star Wars could think of. But it turns out Dawn uses an ion engine also. And in fact, here's an artist's concept of Dawn using its ion engine as it maneuvered into orbit around dwarf planet Ceres just a few years ago. And one of the things that I think is so cool about this is getting to turn science fiction into science fact. And there's a real ion engine operating at a vacuum chamber at JPL here in California where I work. And you can see it really does produce a cool blue glow like in science fiction movies. And here's an artist's concept of Dawn using one of its ion engines. It actually has three, so we do one better than the Star Wars TIE fighters because they only have two. But we use this ion engine to be able to accomplish a mission that would be not just difficult, but impossible, truly impossible with regular rocket engine technology. So there's an artist's concept of Dawn firing its ion engine. And without its ion engine, it would not be possible to fly out past Mars to the asteroid belt and to orbit these two exotic alien worlds, Vesta and dwarf planet Ceres. And this is a really big spacecraft. Those big solar arrays here, you know, they convert sunlight into electricity. From one end to the other is 65 feet. That's the distance from a pitcher's mound to home plate in a professional baseball field. So this was NASA's largest interplanetary spacecraft when we launched it. And the reason it has such big solar arrays is because it went far from the sun. So sunlight is weak. So you need large solar arrays to capture enough sunlight to make electricity. But that's an artist's view of it. Let me show you the real spacecraft. Excuse me. Here it is in a clean room. You know, scientists and engineers have to dress up in these outfits. We call them bunny suits to keep any dust or hair from them settling on the spacecraft, because that could be a problem in zero gravity. And this is one of the solar arrays here, because we fold them up because you can't fit a 65-foot wide spacecraft inside the nose cone of a rocket. And I'll show you a little later how that opens up when it's in space. This is our antenna that we use to communicate with Earth from across the solar system. And here's one of our ion engines. And here's another view of the spacecraft. So there's the main spacecraft again. There's the antenna. Here's my friend Tom. And this is one of the solar array wings. Each solar array is about the size of a school bus. So this is a big spacecraft. So I think that's pretty cool. And when we launched it, we put it on top of a rocket at Cape Canaveral in Florida and had an exciting and I think beautiful launch. And one of the things that's so cool is we launched at dawn, and there's the sun rising in the background. And then the spacecraft was in this nose cone. Once we got up in space, I'm going to show you a video from a different mission that I worked on, Deep Space One. But the spacecraft looks kind of like dawn. And so you can see it opens up those solar array wings. They unfold after it gets out of the nose cone. And then we point them at the sun and turn on the ion engine and say goodbye to the Earth and the moon there, and then head out deep, deep into the solar system, far, far away, in order to explore these exotic alien worlds. And then Dawn conducted a mission that lasted 11 years. And then at the end of the mission, we left it in orbit around Ceres. And this is the orbit that we left it in. And so you can see it goes from high altitude, it dives down, and about once a day, it skims just a little bit over the surface. So it goes up there to 2,500 miles, and then it plunges down to just a little more than 20 miles above the ground. Every day, repeating itself like that. The spacecraft doesn't work anymore. In fact, it lived longer than it was supposed to, but it stopped operating a little less than 2 years ago. But now it's going to stay there essentially forever. So the whole time you're in school, when you're out of school, maybe you'll go to college, maybe you won't, I don't know, but whatever you do, as you grow up, for basically the rest of your life, this spacecraft will be out there deep in the solar system, orbiting the dwarf planet that it unveiled. And maybe even some of you, when you're older, will work on a future NASA mission, or if you don't work on it, maybe you'll read about it, a NASA mission that maybe will go to Ceres and will find Dawn still there in orbit, preserved as a sort of a monument, like a statue, honoring our collective effort to explore the solar system.
So, Mark, I'm just going to pop in for 1 second here. I want to make sure.
That's the end.
Oh, wow. Good timing. All right, Mark. Good job. So I want to visit to get us started, because I know they have to leave shortly.
Right. That's why I moved
sales
along.
group in Forest City, Iowa, 5th graders. I'm going to bring them into the call here so we can say hi. Where are they hiding? There they are. Hey, 5th graders.
There you are. Hi, everybody.
Okay, Nick, go ahead and ask your question.
How far can a rocket ship go?
Did you say how far can a rocket ship go?
Yes.
Okay, good question. What was your name again?
Nick?
Okay, Nick. Thanks for asking that question, Nick. So most rocket ships, like the one I showed you and the others that you see on TV or on the computer and things, they go up maybe 200 miles or so. And that's like where the International Space Station is, just a couple of 100 miles. But then they often, like with Dawn and other missions I've worked on, they release a spacecraft that can then go much, much, much farther away. So the spacecraft that the rocket takes can go not just maybe 200 miles, but hundreds of thousands or millions or even billions of miles away. So like the moon is more than 1,000 times farther away than the rocket goes, but the spacecraft that the rocket carries goes there. And Dawn, the spacecraft I just showed you, is 1,000 times farther than the moon, 1,000,000 times farther than the space station. But it just keeps going. Does that make sense, Nick?
Yeah.
Good. Thanks for
All right. I think there's someone lined up for a second one.
Informative. Okay, go ahead.
Let's squeeze one more, and then we'll let you guys carry on with your day.
I don't know what this question is, so. I don't
What
know.
was the recent rocket ship that you like put off?
What was the most recent?
What was the most recent what?
Rocket ship?
Or
Ship?
something that you know, like you had Dawn up there. What's your most recent?
Well, the most recent that I've had anything to do with is now on its way to Mars. It's the Perseverance rover. And I haven't done a lot with it, but a little bit. It launched just about 2 months ago or so. And February 18th, it's going to get to Mars and land. Maybe you've seen other times when we've landed spacecraft on Mars, or if you haven't, you'll get to see it this time. It's going to put a big rover on the ground, and the rover will drive around and take pictures and make measurements and collect samples and do other scientific experiments. And a cool thing it's going to do is it's going to put a drone, we call it a Mars helicopter, named Ingenuity, on the ground, and that helicopter is going to fly around. So something cool to look forward to this coming February.
Ah, yes.
That
Can't
sounds
wait.
Very cool.
Yeah.
to see that.
Well, Forest City, Iowa, thanks so much for hanging out with us today.
And thank you. Sorry we've got to leave early.
That's okay. Thanks for joining us.
All right. It was very informative. Thank you. Bye.
Bye.
All right, Mark, let's meet a few more classrooms here.
Yeah, that's what I want to do.
Okay, we're going to go to, let's see, Mrs. Ross's group. They're joining us in Tavistock, Ontario. Let's bring them into the call. There they are. Hey, Tavistock, how are you?
Good. I'm good.
Hi, Mrs.
All right.
Ross.
Hi, can you hear us?
We can.
We gotcha.
Perfect. You can talk really loud. We have a question for you.
Okay, maybe I'll have an answer. We'll see.
How long did it take to build Dawn?
That's a very good question, and I do have an answer. It took, I have to remember now, it took 5 years to design it, build it, and test it before we launch. So, before you start actually putting the pieces together, you have to do a lot of work to figure out how everything, what are all the different pieces? How should they fit together? What do they have to do? How are we going to operate it when we get it in space? All of that. So we did that. Then we actually made or bought or built all of the different pieces, put them all together to make the spacecraft. But then you don't just build it and put it on top of a rocket and launch it. After you build it, you spend a long time testing it, because once it's out there, as I told you, 1,000,000 times farther than the space station, if it has a problem, you can't send an astronaut there to fix it. So you have to make sure it's going to work well. And so we spend a lot of time testing it. So the total, again, of designing, building, and testing was about 5 years.
All right, great question. Mrs. Ross's group, get another one ready. We'll try to join you again closer to the end. Let's go to Niagara Falls, Ontario this time. We've got Mrs. Galtieri's group joining us. Let me bring them into the call. There we go. Hey, Niagara Falls.
Hi.
Hi.
Okay, one of our questions was already answered. But another one is, how long did it take for Dawn to reach its destination? So you mentioned it was out there for about 11 years.
Right.
But how long did it take from the time that it left Earth and reached, how long did it take?
Right.
And I think another question was, what was the cost of making Dawn?
Okay.
How much did it cost to build her?
Yeah. Okay. So the first question, how long did it take? So we launched Dawn in 2007. It flew past Mars in 2009, and it got to its first destination, Vesta, in 2011. So 4 years from launch to getting to Vesta. And then we spent 14 months, so a little bit more than a year, orbiting Vesta, we took 30,000 pictures and lots of other measurements, then broke out of orbit. Then it took another 2.5 years and 900 million miles to go from Vesta to Ceres. And then once it got into Ceres, it went into orbit around it too. And then it spent 3.5 years at Ceres. So does that answer that question?
It answers the question, yes.
Okay. The next question you asked was, how much did it cost?
Yes.
And from the time we started designing and building it, through all of the 5 years that I told you about building it, then buying and launching the rocket, then operating it for 11 years, that entire time, spread over that time, was about $450 million, which I would say is a lot of money. But one way to think about it is, of course, for those of us in the United States, I know some of you are in Canada, but whatever country you're in, your tax dollars go for these kinds of government activities. So NASA gets its money from the government, which gets its money from taxes. And so that works out in the United States to about $1.50 per person who pays taxes, which is, of course, all of us, your parents, everybody, and your teachers, and I, living in the United States, pay taxes. So that works out to 75 cents per world. So 75 cents to do Vesta and 75 cents to do Ceres. So I hope that answer makes sense.
Very cool. I think that was a great breakdown, Mark. I like that.
Good.
All right, Ms. Diaz's group. Let's bring them live into the call with us. They are in Miami, Florida, so probably warmer than it is in Canada right now. Let's bring them in.
Hi, Ms. Diaz.
Third graders.
Hi, how are you? Thank you for letting us join, boys and girls. Let me see who has a question, and I will think Catalina had her hand up. Catalina, do you want to go ahead, unmute yourself? Let's see if they can hear you.
Can you hear me?
I can. Hi, Catalina.
My question was, if you go to explore a planet, is it hard finding Earth to go back to Earth?
Wow, good question, Catalina. Very good.
How do you know where Earth is once you're on a planet?
Yeah, that is a good question. And actually, the answer is surprisingly complicated. So let me see if I can explain it clearly. So you know how, well, let me, it's going to sound like I'm changing the subject, but I'm not. If you go out these evenings, like today or tomorrow, or maybe over the weekend, if you look in the south after dark, you can see a reddish, sorry, look near the western horizon, let me just think about it for a second. The eastern horizon, after the sun sets, you can see a reddish object in the sky. That's Mars. And if you look south, you can see Jupiter and Saturn together, near each other. You can see that with your naked eye. And so astronomers keep track of where the planets are, right? We know, even without looking right now, astronomers know where the moon is, where Mars is, where Jupiter is, where Saturn is, and where all these other bodies are. So we have computers that keep track of this. And then when we send a spacecraft to one of those distant destinations, we program that computer to keep track of where Earth is all the time. Just like I'm in California right now. If I drove across the country, I would still know where to look to find a distant destination because I keep track of it with my computer. And so we program these computers so they always know where Earth is from their point of view. Does that make sense?
Yes, yes. She said yes. Catalina, say it again, baby.
Yes.
Good. Well, thank you for that question, Catalina.
All right. Mr. LaVogue is representing his students in North Palm Beach, Florida. Let's bring him into the call.
I'm doing great.
How you doing?
We are on the coast in North Palm, about 2 hours south of Kennedy, and we can watch launches from our playground at school.
Wow, that sounds like, I wish I'd gone to your school.
Yeah, it's pretty cool. So my students are texting me questions. So you had mentioned on Ceres the salt water underneath the surface.
Right.
Sophie, about sixth grader, Sophie wants to know, could there be life in the salt water underneath the surface?
Yeah, Sophie, that's a good question. We would like to know the same thing. So I should tell you, it's very, very unlikely. It's very unlikely. Ceres is, well, we've never found life anywhere other than on our home planet here on Earth. So we don't know enough yet to know what conditions are responsible, what combinations of chemicals and the environment are needed for life to form. We know that Earth had whatever those circumstances were, chemicals and environments, but we don't know enough to know what's required elsewhere. We do believe that Ceres has many of the, you could think of it, ingredients for the recipe of life. Ceres has water. It has enough internal heat to keep some of that water, most of it's frozen, but to keep some of it liquid. Our sensors on Dawn have detected some of the chemicals that we know are important for life, but we just don't, scientists don't understand yet exactly how all those things combine to make life as it happened on Earth billions of years ago. And Dawn did not have the equipment to study what's happening deep underground with enough detail to know whether there's life there or not. So again, I should emphasize, it's highly, highly, highly unlikely, but we can't say for sure. And one of the things that NASA and others are interested in doing is looking for life elsewhere in the solar system to try to learn more about how it came about. It was sort of a rambling answer, but I hope that answered Sophie's question.
I think so. Awesome, Mark. We're going to visit Joe and Zeke. They're hanging out in Wisconsin. How you guys doing?
Joe and Zeke?
Good. I had a question of how heavy is the Dawn spacecraft or shuttle thing?
Yeah, no, the question you asked was just fine. How heavy is it? And you know what? I'm embarrassed to tell you that I need to convert it because scientists often use kilograms, and you probably want to know in answers, and I didn't remember you wanted to know in pounds. So when we launched it, it was just a little less than 2,700 pounds. So more than a ton. But now, of course, some of that was the propellant, the fuel that we use. That ion engine, 900 pounds of that was xenon gas, xenon propellant. So it was a little less than 2,000 pounds of sort of what you might think of as the empty spacecraft. Does that make sense?
All right, great question. Let's see if we can squeeze in a few more. There's still some time, Mark. So I'm going to go back to Mrs. Ross's group and see if they have a follow-up for us.
Yeah.
Hi, we have another question for you, and here's
Sure.
Michael.
Hi.
Hi, Michael.
Have you ever had to fix like a really important part when you were testing?
We have. So a number of times when we're testing spacecraft, there will be some problem. And that, of course, is why we test the spacecraft before we launch it. So I'll just give you one example. Dawn has, you can think of the main spacecraft structure is sort of like a box, and then it has these long solar wings. But the box has mounted to it, and when I say box, it's big. It's bigger than I am, bigger than you are. It's about 8 feet high or so. And it has various devices connected to it, some of which are bolted on, but some are actually glued on. And when we were testing the spacecraft, we took it down to very, very, very low temperatures, much colder than we get on Earth. And one of those devices that was glued on, the glue actually cracked. But that's okay. That's why we tested it on Earth, to make sure it could handle these low temperatures. So we took it back out of the test chamber that it was in, and used a different kind of glue. And when I say glue, it's not like the kind of thing you would find in in an arts and crafts room at school. These are special glues, but we switched to a different one that was even better able to handle the really low temperatures, and fixed it so that when we launched it, it would work well in space.
All right. Very cool, Mark. There's lots to think about before something can launch, and a lot of troubleshooting, a lot of problem solving. It must be fun to sit on some of those sessions.
It is, but I'll tell you, the coolest part of all is when you really have the spacecraft in space. To me, there's nothing neater than going out. I know maybe I'm taking more time here than you want, but to just think about it, and all of you can do the same thing. I mean, I'll tell you, when I go out and look at the night sky, I don't just think, wow, the stars, the planets, all that is so cool, and what else is out there? I also think we have things out there. You have things out there. I mean, these missions belong to all of us. It's not just people like me at NASA. It's everybody. These are Earth's missions. These are humankind's missions. These missions represent all of us. I don't know if you know what an ambassador is. It's somebody who represents your country to another country. Well, I think of these spacecraft as ambassadors that represent our planet, Earth, to the rest of the universe. And so when they're out there, and when I look up at the night sky, I think, wow, we have spacecraft there. I mean, isn't that cool? And so, yeah, it's really neat to work on them when they're here on Earth, but I think it's a lot cooler to think about how amazing it is, and how lucky we are to be able to live in a culture that's capable of bringing together scientists and engineers and others to build and launch these spacecraft and operate them on behalf of all of us. I think that's really cool.
Absolutely, Mark. And I think that's, I think that's going to have some of the students today going home and looking at the sky in a different way, that we have those things out there and so far away. And it's pretty amazing.
It is amazing.
Mr. Laveau, let's bring you back in. Do you have another question from your group?
Yes. Evan wants to know if you could do an equivalent. You got our interest with the Star Wars reference and the ion engines.
Yeah.
So we've had some chatter about that. And Evan wants to know, can you do what is like a horsepower of an ion engine? Is that something you could equate?
I could. In fact, I'm going to lean out of the thing here for a second. So the ion engine, I can't give it to you in horsepower, but I'll give you a different example. The ion engine pushes on the spacecraft as hard as this piece of paper is pushing on my hand. Isn't that bizarre?
It's incredible.
It is. And so you'd think, that sounds useless. Why would I want an engine? Normally, I mean, you think of these things as pushing hard, right? The difference is that with a normal rocket engine, you fire it for a few minutes, or on a spacecraft, maybe over the course of the mission, an hour. And that's all you can do. But the ion engine, instead of pushing for a few seconds or a minute or an hour, you actually use it for years. And gradually, the effect of this gentle force builds up. So I'll tell you, for people that are like cars, it would take Dawn 4 days to accelerate from 0 to 60 miles per hour. Doesn't exactly make you think of a drag racer, but instead of thrusting for 4 days, if you thrust for a week or a month or a year, or as Dawn did for almost 6 years, you can achieve fantastically high velocity. So this is what I like to call acceleration with patience. So in Star Wars, the TIE fighters and the X-Wing fighters, which also use ion engines, they're very maneuverable. And if, I've always thought if I'm in a ship and somebody's shooting at me with their laser blasters, I'd rather go for maneuverability than fuel efficiency. But real ion engines, they don't give you that much maneuverability, but they really win on fuel efficiency. And they have like 10 times the efficiency of conventional rocket engines. So your parents' car maybe gets 30 miles per gallon. And they use miles per gallon in Canada, or
liters in Canada.
Okay. Whatever it is, an ion engine would give you like 10 times better. So you could go 10 times farther, or with the same, with the same amount of fuel, you could do 10 times as much flying around. So I know that was a little bit of a long answer, but I hope that was.
Thank you.
Sure.
All right, Ms. Galtieri's group, I'll bring you back in. Do you have one more question?
What was that question? How many asteroids are in the asteroid belt? I don't know. And the other one was, if you found, sorry to interrupt, if there was life found on that planet, what would be the first steps?
Okay, so first is, how many asteroids are in the asteroid belt? The answer is millions. Now, we don't know exactly how many millions, but millions. So, and they range in size from, I should start at the tiny, particles of dust to, little pebbles to, things the size of a baseball or softball or basketball, beach ball, boulders, things the size of buildings, things the size of mountains, to things that are tens, hundreds of miles in diameter. So over that whole range, millions. Just as an aside, before I get to it, Dawn explored the two most massive, the two largest. So the first one it went to, Vesta, is 300 miles in diameter. And Ceres, the dwarf planet, but dwarf planet that lives in the asteroid belt, is almost 600 miles in diameter. And it's got more than a third of the area of the continental United States. So some of them are big places. And then the other question you asked was something about life. Was it, what would be the next step? Is that what you said? I apologize for.
Yeah, that was the next question. What would we do next if we thought there was some evidence?
Okay, well, I'll tell you the next thing we are going to do. And that is, NASA is studying, hasn't decided yet whether it's going to do it, sending a spacecraft to land on Ceres and collect a sample and bring it back to Earth so we could have it in scientist laboratories on Earth. When you send a spacecraft somewhere, you have to keep instruments, the scientific instruments, small and lightweight and low power. But if you can bring material back to Earth, then you can use the sort of the full scientific power of what we have here on Earth. And so the next thing really would be to try to bring back some of that material so we could understand it better. And while the spacecraft is on the ground, to try to probe deep to learn more about what's on the ground in more detail and what's underground. Now, NASA can't afford to do everything because, there's a big solar system. There are a lot of cool places to go, but that's one of the missions NASA is studying now. And if it went, by the time it did it, all of your students, all of you will be adults at that time. Maybe you'll participate in the mission, or again, if not, maybe you'll at least read about it and follow it as it goes.
All right, Mark, do you have time? We'll do maybe one or two more visits.
I do if you do.
Oh, absolutely. Let's see if Ms. Diaz's group has a final question for us.
Yes, we do. Alonso, you want to go ahead and unmute yourself and ask your question, buddy?
So, will you ever go to Andromeda?
I didn't catch all of Alonso's questions. Will I ever go to, was it Andromeda?
Yes, that's what he was saying.
Okay. So Alonso, I'm impressed that you know about Andromeda. That's really cool. let me first tell everybody else about it, just in case they're not familiar with it. So, we live in a galaxy called the Milky Way galaxy. And it's a huge place. It's got hundreds of billions of stars. One of those stars is called the sun. That's the star that, you and I see every day. But there are more stars in the Milky Way galaxy, many more stars in the Milky Way galaxy than there are people on Earth. So that's a galaxy. Andromeda, which Alonso was referring to, is another galaxy that's similar to the Milky Way galaxy. And it's very far away. If you ever hear scientists talk about light years, it's more than 2 million light years away. And so Alonso asked if I would ever go there. I never will, because right now we don't have the capability to send astronauts any farther than just, again, a couple of 100 miles. And pretty soon we'll send astronauts to the moon and then eventually to Mars. But other stars in the Milky Way galaxy and then other galaxies like Andromeda are so incredibly far away, so unimaginably far away. So, it's really hard for even scientists like me to really kind of, as people say, to wrap your head around how amazingly, awesomely far away these other places are. Not in my lifetime, not in your lifetime, not in the lifetime of your children or grandchildren or their grandchildren will we be able to send people to Andromeda. But you know what? We can look at it with cool telescopes. The Hubble Space Telescope, pretty soon another telescope that NASA is going to launch called the James Webb Space Telescope, other telescopes in space and on the ground. We can get great pictures of it. And I hope you and others, Alonso, that you and other students who are interested will look for pictures of other galaxies and think about, in those galaxies, there are all these stars, and around those stars surely are more planets, and maybe there are even some planets like ours. The universe is an amazing place.
All right. And let's bring in our group in Wisconsin, Joe and Zeke, and see if they have a final question. Hey, gang.
I have two that are kind of related. How many dwarf planets are there, and how many dwarf planets have you explored?
Okay, so the first one is, how many dwarf planets are there? And we don't know how many dwarf planets there are, but they're probably, we've already identified, and I'll tell you the truth, I don't even keep track of them now, but probably already identified, that is, found with telescopes, objects that upon further study will be classified as dwarf planets, more than a dozen, and maybe even many more than that. I don't even keep track of them now. It first started, the first one that was discovered was Ceres, which I showed you. That was discovered in 1801. And then the second one that was discovered, Pluto, discovered in 1930. But since in the last 20 years or so, many, many more have been discovered as we get more advanced technology. So we have better telescopes. Astronomers have better capability to observe these distant bodies. And I apologize. What was the other? Oh.
How many have you explored?
Okay, well, so I personally have only been involved in exploring one. That was Ceres. There was also a mission, though, that flew by Pluto. So that's the only other dwarf planet that's been explored. So now Ceres, Dawn orbited it and spent 3.5 years there making many, many detailed measurements. We took more than 70,000 pictures and got a lot of other measurements. For Pluto, the spacecraft just zipped by like that and got some really, really cool pictures and other measurements when it went there, but it didn't get to explore it in detail like Dawn did. And no others have yet been explored, but I'm sure more will in the future.
All right, Mark. Well, I want to start off with a huge thank you to the groups tuning in via YouTube. A huge shout out to our camera classrooms. Thank you for all of your great questions from different spots in Canada and the US. And Mark, it's always great to steal some of your time. Thanks so much for taking us on a journey, but filling in so many of the blanks and so much behind the scenes that made Dawn happen.
Thank you, Joe. I appreciate the opportunity. And what I really appreciate is the opportunity to connect with all of you students. And thanks to your teachers or parents for organizing this. I'm glad that they take the interest to let you see some of the amazing things that scientists and engineers are able to accomplish. But can I just make one more brief comment? Do we have time? I should tell you that, you know, it takes a lot of people to do this, and maybe some of you are interested in doing it, maybe some of you aren't. But I've mentioned scientists and engineers a number of times. You know, there are a lot more people than just scientists and engineers involved in these kinds of projects. You know, we spend taxpayer money, and so we have lawyers and business people and people who understand how contracts work and excuse me. And we have technicians who maybe some of them haven't even gone to college, some have, but others haven't, who work on these projects. And we have secretaries and all kinds of people. So what I want to tell you is there are a lot of different careers you can pursue if you're interested in, and still have the opportunity to work on projects like this, if that's something that you're interested in. It takes all kinds of people to make these things work. And I think that's pretty cool too.
Absolutely, Mark, 100% agree. And again, thank you for your passion, your enthusiasm, because I mean, it's very apparent in the way you talk about your projects. It's apparent in the way you talk about space exploration, and it definitely rubs off on students. So thanks so much for today, Mark.
Thank you.
All right. Well, we're going to sign off for today. Thanks, everyone, for joining us.